All right, good morning, good afternoon, everyone. Welcome to today's session. It is 9:30. We will be getting started. I'm going to give everyone a minute or so just to hop on. In the meantime, we have a chat session going on. Please feel free to drop in, where you're joining us from today. And if you have any kind of questions or expectations from the session, we'll happily try to cover that before we get started. And in the meantime, please let me know if anyone is having any issues at all in, seeing my screen, hearing my voice. Feel free to post something in the chat if you're having any issues there. All right, so it's around a minute or so. So I'm just gonna give everyone another minute before getting started. So to everyone just hopping in, thank you for joining today's tracing troubleshooting presentation. We're gonna be going over quite a few topics here today. So we have a tight agenda, and I would really encourage everyone to ask questions in between. I will be monitoring the chat and Q&A section. So if there's any questions at all, please do feel free to drop in a chat. All right, let's get started. So thank you everyone for joining today. My name is Bhargavi Ketha. I am a technical consultant on the professional services team here at Sumo Logic. I've been at Sumo for around 3 years, under the professional services team here in Sumo. So if you're not aware, we have a professional services team who conduct, projects and engagements for customers to quickly get onboarded into Sumo Logic and, get started with some of our observability and security-based platforms. So today, welcome to Illuminate 2022. I know this session is very interesting. We're going to be talking about tracing. We're going to be doing a couple of troubleshooting sessions around tracing in general, and talking about how Sumo can help you in understanding overall observability into your microservices or distributed applications. So just kind of a quick housekeeping check. If at any time you are having any issues hearing my voice or seeing my screen, please do drop a note in the chat. I'm happy to, kind of reset everything there. Additionally, please do let me know if you have any questions. We want to make this session as engaging as possible for you. If you have any questions, and if there's something that, we cannot resolve on the session today, happy to take it offline. I'm going to put in my email address. So if you have any questions during or after the session, please feel free to reach out, and I will try to answer questions and keep an eye on the chat in the meantime. So with that being said, we have a good number of folks already joined, and we have a recording going on. So I'm sure we're going to be sharing those recordings out afterwards. So without any further ado, let's get started. So for those of you who are just joining in, quick introduction again, I'm Bhargavi Ketha. I'm a professional services technical consultant focused on the observability side at Sumo Logic. And today we're going to be going through tracing troubleshooting. So the agenda is pretty straightforward, right? We want to keep it as simple as possible, just trying to get your feet wet with, what tracing is, how Sumo Logic can help you with tracing. We're going to be going over a few concepts like what is tracing, what are tracing concepts, what is a trace, what is a span, some basic things just to help you understand and that you're not completely thrown into the dark. We will be doing a little bit of programming. Now, if you if you're not familiar with programming in general, that's perfectly fine. It's a very, very simple Python program. And if you have Python up and running, I'm sure you can follow along really quickly. All we're doing is running a simple web application locally. And we're going to see how we can generate traces and what are the steps required to get tracing data into Sumo Logic. So we're not going to be going into too much detail of containerization. We're going to try to keep it simple and focus on tracing without being carried away with how do we deploy the application and getting into the specifics. All right, so we have a good number of people. We have people from India, from Seattle, from Cleveland. I'm from California, so we have really great weather outside. So thank you for joining today. All right, so the next kind of topics are, what is tracing architecture when it comes to Sumo? And when you're talking about tracing architecture, what are the things you need to think about? Additionally, what are the instrumentation steps for a simple Python application? Now, of course, this is going to depend on your own kind of application and your programming language requirements, but hopefully this will give you an idea of where to get started and where to go if you're ever stuck, right? And that's the biggest portion of troubleshooting. What are the common things we see customers going through and struggling? And if you are stuck somewhere, how can you sort of get help? What are the things you can try on your end? What are the basic things you can do to understand whether you're successful in getting tracing setting up and sending it to Sumo? We are also going to spend some time to go over some of the out-of-box content. So, you have traces, everything's working. Now, what do you do? Like, how can you get value from the data? So that's why the last kind of 3 bullet points are like dashboarding, what you can do with dashboarding, some tips and tricks to understand if everything's set up correctly, and essentially like where to go for help. We will try to keep a dedicated 5 to 10 minute session for Q&A, but my hope is that during the course of the entire session, we're asking questions. I'll be doing pauses here and there. We have 60 minutes together, so let's try to make the most of that time. All right, and I will request if everyone could go on mute if possible. That would be very appreciated. I will try to mute folks who have accidentally gone off mute, but apologies if I am unable to do so. Thank you. All right, so before we get started, right, what is tracing? Like, why are we talking about this topic? And why is it important? So in the realm of open microservices architecture, it's become very important to really understand not only from individual errors for an application, but to understand the entire user journey as they go through, as the user is going through an application. What is the journey as different calls are made to different microservices? And this is where distributed tracing comes in. It's essentially a method of observing the requests as they're propagating through distributed cloud environments. So distributed tracing is essentially following an interaction, and we're essentially tagging what we call a unique identifier as a particular request goes through the system. So what this means, what this essentially means is that we have in the past, we've had monolithic applications where, we were able to really understand where things were going wrong with the application. But over time, we needed to figure out a way to understand where things were going wrong. And we needed a framework that would support this generation of tagging and unique identifiers and getting that telemetry data, which is essentially what the trace is doing. So as monolithic legacy applications are giving way more to nimble and portable services, the tools once used to monitor their performance are not really up to the mark when it comes to these complex cloud native architectures. So essentially, the complexity was creating some internal collaboration challenges, as you might know, to understand which service is causing the delay and latency, and overall understanding the user experience as they go through your application. So some of the benefits of distributed tracing, it helps teams get to the bottom of application performance issues faster. We're trying to make sure that users are noticing things before they go wrong. And if there's any issues, we want to make sure that those can be resolved. And because distributed tracing is essentially pinpointing the exact areas where this issue helps, it's helping that kind of collaboration across teams to understand what's causing the holdup. So we're not going to be going to too many details, but when we're talking about architecture for modern applications, right, we might have multiple microservices as your monolith gets broken up. And we're trying to really understand these complex applications as they leverage distributed technologies, cloud infrastructure, container and orchestration tools, and the connections between those different microservices. And this is where tracing comes into play. And this is a really great quote, essentially that we have regarding tracing where, replacing a monolith with microservices. So it becomes that every outage could be more like a murder mystery where you're trying to figure out which service is causing the issue underneath your entire complex architecture here. So a couple of things, right? We are going to be looking at overall applications performance as, of course, logs, metrics, and traces. Today's focus is going to be on tracing to understand the entire transaction in totality. As we navigate the user request from different services and their connections. And this is going to be a really great topic to go into more detail. So essentially, a transaction trace is giving us a detailed snapshot of a transaction lifespan across the entire application environment. So you're essentially following the course of a user's request from its source to its ultimate destination to monitor and profile your microservices architecture. So tracing is definitely the backbone of the observability solution. Now, as we go further, there are some important terminologies that we would like to go through, right? Apart from the general, like what is transaction tracing? So a trace, what is exactly a trace? A trace is something that's recording the path taken by the request. And this is a UI snippet of in Sumo Logic, how you can look at different spans put together to build in a complete trace. And here is essentially a really good example of like an application called a coffee bar front end, where you're essentially having a trace that is made up of a bunch of spans. Now, what is a span? A span is essentially representing a unit of work or operation. It's tracking operations that happen throughout the course of a user interaction and trying to paint a picture of what happened and when it happened. Now, in order to build and stitch this particular trace, there are a couple of things that are required. And this is what we call the span ID and trace ID, which you're going to be seeing quite often in the UI. And just to make sense of it, it's essentially a unique identifier, right? So it's a 16-byte randomly generated number, and it's essentially used to group all the spans for a specific trace together across all of the processes. And similarly, span ID is another thing that allows us to understand, what type of operation and what, when it's being passed on to a child span, this identifier is also being passed on so that we can finally stitch the entire trace together. So those are a couple of different interesting terminologies. Now, for some more information and where most of this information was brought is our OpenTelemetry, the open source OpenTelemetry site definitely has a lot of great glossaries and terminologies regarding this and understanding things like context propagation, how the traces are essentially being propagated with the trace ID being sent over from child span to parent span so that we can stitch the trace together. But as you can see, right, like distributed tracing, it tracks the progression of a single request as it's handled by services that make up an application, and it transverses the process, network, and security boundaries. So a lot of the items found on the slides here are definitely taken from this open source OpenTelemetry site. So I would definitely recommend checking that out. Now we're going to go into more of the collection architecture piece. So we've talked about, what is a trace? Why is distributed tracing important? We talked about the monolith, we talked about microservices, how it's getting harder to understand, how microservices are working together, and, how we need to build that entire user request view as a particular user request goes through your system, and trying to pinpoint that particular area where things could be going wrong, that you would want to get an understanding that maybe your logs and metrics single-handedly might not be able to stitch that picture together. We also went through the concepts of trace ID, span ID, why they're important, how they're being used in building this entire tracing view. So now is a good time to go into the collection architecture. So onboarding data into Sumo Logic is very straightforward. We're using OpenTelemetry, which is essentially, part of the open source industry. It's vendor agnostic. So we're trying to, we're going to be going through the different architectures into getting data into Sumo. For today's particular tracing troubleshooting, I am going to be doing an auto instrumentation of an application with Python. And we are going to be essentially, the main steps that we're going to be following are we're going to be instrumenting the code So this is the first step for any sort of tracing. We need to take a look at your code, and we need to instrument it so that it essentially is able to take all of the libraries that you're using and automatically, instrument it so that, it generates the traces and spans required for us to collect those traces and spans and send it to an observability platform like Sumo Logic. So there are a couple of steps, right? We need to, first of all, instrument your code. We do then need to have a collector to collect those traces. And we need to send it to a platform like Sumo Logic to essentially showcase those traces and spans for further observability. So in this instance, I will be going through a Python application. And if you did want to follow along, it's very straightforward. We're going to be going through just a very simple Flask application. We are essentially going to instrument a simple web application, and that will essentially generate traces once we have completed the auto instrumentation portion. And it's going to send the traces into Sumo Logic once we have the collector up and running. All right. So before we kind of go into it, right, we have the OpenTelemetry collector, which we're going to be using today from Sumo Logic, which is essentially the collector that is going to be running, that is going to be collecting the traces. So for more information, you can definitely go back to our OpenTelemetry docs there, where we have gotten some of this information. And this is definitely maintained and open source. So essentially, we have the OpenTelemetry collector, which can either run as an agent or gateway, which basically means that, this is going to either be running on the same instance where your application is running, or it's going to be running on a separate instance, acting as a gateway to essentially collect traces from different systems and, process that data and send it over to the Sumo receiver. So you can see, like, for example, in like like an ECS cluster or something of that sort, you could have different services running, and they would essentially be sending it to an OpenTelemetry collector, which is running as an agent. That means when a collector instance is running with the application on the same host, that would be running as what we call in the agent mode, whereas a gateway is a separate instance that's running on a standalone service or a container or deployment, and it's going to retrieve all the data, process it, and send it to the backend. So if you are interested, we'll be sharing out the docs, of course, the slides, but, what's the difference between an agent and a gateway? Why would you choose one over the other? And it is recommended to have the agent deployed on every host, because there is certain metadata about the host and its OS that's residing on the host, which would recommend you to have the collector running as an agent on the node, apart from a gateway, which can help with things like tail-based sampling. These are kind of a little bit more advanced topics. We're going to be getting into that a little bit more, but just know it's easier to scale the architecture, and it's kind of like a consolidation point to process and send like via batch processing into Sumo Logic. We are going to be going through a couple of other things, but before going into that, I did want to walk you through the application. So I will tell you the instrumentation prerequisites in order to really try this out for yourself. So all you really need on your environment, right, is the installation of Python and Flask, right? So you can do a quick pip install Flask, and you can now run a simple application via around 4 lines of code, right? You just need from Flask, import Flask, and then you just need to return a web page that just says hello world. And that's essentially what we're going to be showing here. So this is a really simple, very, very simple application. I am running on port 5081. A couple of things, right? In order for Python Flask apps to work, you do need the debug flag to be set to false. So if you are following along, just remember that you do need this to be set to false in order to get traces to work. But all I'm really doing in this instance is I am essentially returning a message that says hello world, and that will be displayed on different ports. So I have 2 applications running to show you how you can essentially have 2 microservices running and then generate traces and send them over into Sumo. So let me go back to this and kind of give you an overview of what you need to do to actually instrument your application. And I'm going to take 2 steps back. So just to kind of level set, right? We talked about quite a few things. We talked about what is tracing, why do we need tracing? We talked about the fact that we need 2 things in order to get traces to work, right? You need to instrument your application, which means you need to have certain packages that are provided by OpenTelemetry that actually does the hard work, right? The reason why we're actually installing these packages is because OpenTelemetry is essentially doing this hard work for you. They are actually providing the packages that are going to be doing the stitching, the generating of the traces. So you don't have to actually go in and manually instrument your code. Now that is a possibility, right? So we have what we call auto instrumentation and manual instrumentation. So if you're ever curious on if you want to ever go down the path of manual instrumentation, just know that an application that's instrumented with OpenTelemetry can either be done with something called auto instrumentation or manual instrumentation. Now, the main difference is manual instrumentation does require the user or the developer to actually go into the code and, make changes to actually do that type of stitching. But the challenge there is while it provides a lot of customizations, it is a little bit more involved, and you will need to really understand OpenTelemetry SDK and API on how to do those things. So for today's session, we're going to be focusing on auto instrumentation. And what that means is that OpenTelemetry has support for certain libraries. So if you were to take a look at your application, let's say Python, the first step I would say is first take a look and see if the libraries that you are using are supported by OpenTelemetry and how you can do this, right? So let me go back in here. So when you go into Sumo Logic, and if you go into our getting started with transaction tracing, so this is the Sumo Logic help docs. I'm just walking you through it really quickly. There is one doc called, Python OpenTelemetry auto instrumentation, and there's one specific for every language. In here, they are going to give you what we see a list of supported libraries under OpenTelemetry instrumentations, right? So what this is saying is that in order to capture telemetry data from Python written code applications, OpenTelemetry, our choice here, OpenTelemetry, has given us a list of libraries that they support. So in my application, I'm using Flask, and you can kind of see here, right? Flask is supported. So that means that whatever libraries that are supported here, if I'm using those, then OpenTelemetry knows what to do with that and knows how to inject the traces and the spans and doing all that back-end work that, I don't have to spend time on. So if you're new to tracing and you're trying to figure out what is a trace, how do I get traces really up and running really quickly, this is a really good way to get started. Just trying auto instrumentation instead of going into manual instrumentation. Now we do support manual instrumentation, of course, but for today's session, we are going to recommend auto instrumentation if you do not prefer to change application code. And that's the beauty of this OpenTelemetry auto instrumentation. You're not touching your application code. You're just introducing some dependencies here and there that will do the actual work underneath. So going back, right? For Python, a couple of things you do need to have are some mandatory packages installation. And in this case, if you can see here, we do have in my little diagram here, and I like to visualize things. So I kind of put everything on one slide to understand all the steps you need to do. So the final goal is, right, you want to get traces into the Sumo Logic UI. How do you do that? First of all, you need to have some type of application. And that's the example application I provided, where you have a simple Flask app that's up and running. The next thing is you need to introduce these mandatory packages installation. This is really important because this is kind of like the secret sauce, right? This is doing all of the actual work without you actually touching your application code. Then what we need is, in order for things to work, you do need to set up some environment variables that are needed for the configuration. So things like, hey, are we going to, where are we sending the OTel traces exporter, right? So you don't have to get into too much detail of what they're doing. Just know that the last two, right, the service name and the resource attributes, are the ones that you need to customize to include your service name and your application name. And I'll walk you through how we do this. But once you have the environment variables, all you really need to do is you need to use the OpenTelemetry instrument command to run your Python application. Now, again, this is not a containerized application. We're not using Docker or Kubernetes. I'm trying to make us focus on traces. So if you are, if your application is running in Docker or Kubernetes, we do have documentation on how to do that. But for today's tracing troubleshooting, we're going to be focusing on non-containerized applications only. So you have the application, right? It's running. You have done the instrumentation, and hopefully, you know, everything goes great. What next? The next part is you're going to actually install the OpenTelemetry collector. This is the collector that's going to collect the traces from your application, because if the traces aren't going anywhere, they're being generated, the spans and traces, but if they don't go anywhere, you're not going to get them into Sumo. So on the Sumo side, we do need a couple of things. We need to have something called a Sumo HTTPS traces endpoint URL. And then you're going to also need to download the collector, install it, and you're going to need to have a config.yaml file that is actually going to do the important linkage. What that means is this config.yaml file is going to tell you, okay, we're going to collect traces from the OpenTelemetry collector. We have something called a receiver and a processor and an exporter in the config.yaml file. And what that does is it'll essentially send over all of the traces to the endpoint URL that you generated from Sumo Logic. So without any further ado, let's actually go into Sumo Logic, the UI, and let me just walk you through this really quick. So I'm going to log into Sumo Logic. And the first thing that you're going to do is you're going to go into Manage Data Collection. And you're going to essentially take a look. And over here, I have a couple of different things. So I am going to just, you know, expand none of these. And the first thing you're going to need is you're going to need a hosted collector, right? So in the case of tracing, I have a couple of different things, right? I have a Flask app, a Django app. You know, these are all these testings that I've done. So all you would really need to do is once you have a hosted collector, and if you're not familiar, a hosted collector on the Sumo side is essentially a collector that we host on your behalf. And all you would really need to do is add a quick source. And in here, you have a lot of different sources. Now, not to be confused between HTTP logs and metrics and HTTP traces, we're going to be using the HTTP traces endpoint. And once you have that, you can say tracing _ endpoint, or you can give it a name. So I can say Illuminate 2022 tracing example. And yes, we will definitely share the slides. So once you hit save, right, it generates this endpoint URL. So keep note of this endpoint URL. You are going to be using it later. The next thing is we are going to actually set up the application instrumentation portion. So I'm going to go back into my environment here. So to walk through this, right, I have a Flask app that's just running, and I already have one running here. And I have the, I'm going to show you on this terminal how to do the next portion, right? So I'm going to do a quick ls, right? So I have my app.py, which is over here. It's very simple. And what I'm going to do is I need to set up the environment variable. So I have already downloaded the dependencies prior to this. So what that means is I have already done the pip install of the OpenTelemetry distro, of the exporter OTLP proto HTTP, and I've done all of that. So that portion is done. Now, all I really need to do is I need to go ahead and export the temp environment variable. So in this case, it's these four, right? You need the OTel-metrics exporter. And if you're ever not sure whether your environment has all of the environment variables, you can put in a quick print environment, grep OTel, and you can see that they've already been set, right? So I have the OTel-metrics exporter, the OTel traces exporter, OTLP proto HTTP. That is where we're sending our data to. And then we have the endpoint, which is either localhost or the collector URL. Now, this is a really good time to go into kind of, you know, how do we know what values to set here? So this is the time that I do want to walk you through a little bit of the documentation, right? So we have the packages installation dependencies done. You know, we have the application specific packages installation, and we have all of the instrumentation configuration already that is required by Sumo. So we'd let you know what we need, what you needed to set to, so you don't have to do any guesswork here. So I'm going to put this link in the chat if you wanted to follow along. So over here, you have the OTel-metrics exporter, you have the traces exporter set to a value that's saying that we're setting the exporter to OTLP HTTP, and we're going to send the endpoint to, in this case, I'm running it locally, this will be localhost, but depending again, right, if you are in a Kubernetes environment or in another like containerized environment, there are different available endpoints that you will need to use. So this one will really depend on your environment. Since I'm running in a non-Dockerized or non-containerized environment, I was able to get away with just using simple localhost. These are the two that I was telling you are going to have the customizations of the service name and the application name, right? So once that's done, and I'm going to go back to my environment here, and apologies if I'm going through many screens here. So I'm going to clear this. And just for a quick environment check, right? I have 3 terminals running because I want to show you how you can run the OpenTelemetry collector simultaneously as 2 services. So I already have 1 service up and running. You can see here, right? I ran the OpenTelemetry command for app1.py. It is running on port 5051. The other application that I'm going to be running right now is it's going to be running on 5081 port. So this is a really quick way to do dependencies and all of those things. So what we're going to do, right, is we're going to export all of the environment variables. So what that means is all you really need to do is run these commands, right? I'm going to show them here. So all you need to really do is run these 5 commands, export OTelemetrics traces, and I can put this in the chat as well if you would like that. So once you run these 5, right, what this will do is it's going to set the service name. So I'm going to call this Illuminate 2022 service. I'm going to call this Illuminate 2022 app. So now all I need to really do is run these commands. I'm going to do a quick time check. I know we have only 30 minutes left, and I want to make sure we get through this whole thing. Okay, so we have all of the environment variables set up, right? And this is for the auto instrumentation portion. So I'm going to delete this. Okay, now if you remember, we're done with the environment variables, we're done with the mandatory packages installation. So now we need to actually run the instrumented application. So you have this command called OpenTelemetry Instrument, and that is what's going to do the magic here. So what you're going to do is you're going to go in here, you're going to grab this, and I'm going to run, and my app's name is called app.py. Okay, so it's running on 5081, okay? Now, so what this means is I have 2 applications, and I'm going to walk you through what they're doing. So I'm trying to run an application that essentially goes to app 5051, the application running on 5051. It's doing a REST API call, essentially. So I have both of them running. So what that means is when I access localhost 5051 and 5058, 5058 application is going to do a REST call to 5051 to display hello world. So what that should do is in the environment that you're sending the traces to in Sumo Logic, it's actually going to sorry, I see the question here. Yeah, so its application is made up of multiple services. In this case, I'm considering these to be 2 different applications and 2 different services, just for the sake of convenience. But if you have an application made up of multiple services, then you would probably need to set the resource attributes accordingly. Thank you, Bryce and Matt. So in this instance, right, I have those 2 things running, and I have the OpenTelemetry collector running as well. So what that means is we're done with the instrumentation portion. We have generated the HTTP traces endpoint URL. And the last thing is we need to run the OpenTelemetry collector binary. So what that means is in my documentation, this is the one for generating traces and setting up the traces collection. We are essentially using this environment, right, where we're essentially having our service running. It's going to use the OpenTelemetry collector that's running. And in this case, I'm not using a gateway just because this is a local environment. So I'm just running it in the agent mode. And all you really need to do is once you have the traces endpoint URL, you're going to essentially grab the config file. So Sumo Logic provides you the config template available. So you can essentially grab that telemetry gateway configuration config file. And what this will do is, and we were talking about this earlier, this config file is basically telling the OpenTelemetry collector what receivers to use and what processors to use and what exporters to use. So This seems like a lot, but all you really need to realize is that the only thing you need to really change in this config file is the endpoint URL. So all you need to do is grab the correct template, right? Whether you're running it in the agent mode or the gateway mode. So in our case, we're going to be running it as agent mode. So I'm going to grab this config file. And all you really need to do is grab the raw file, and then you're going to grab it. And then in my environment over here, I already have the config file here. And all I did, right, was change this endpoint to use the endpoint that I generated from Sumo Logic. And which endpoint is that? It is essentially this one. The one that we had used, that we had grabbed. All you need to do is change that config.yaml to point to that endpoint. And that is what's going to tell Sumo Logic that's going to tell the OpenTelemetry collector that you're going to be sending all of the traces that you are getting from your receiver, from your application to Sumo Logic. So once you have the collector up and running, and these are the commands to do it, right? You need to get the config file, apologies. So you're going to get the config file, you're going to, run the collector using this command here, /otel collector, and you're going to provide a parameter to, point it to the config.yaml. And I've already done that here. So the collector is up and running. You can see that it says collector's dunning, it's beginning and processing the data. Now I can go in and actually access the websites. So you can see 5081. And if I do this a couple of times, what you should now see is that we have both services running, okay? And then when you go in and you've completed all of these steps. So the last step is to actually go into Sumo and see if you're getting the data. So in this instance, this is my Sumo Logic environment. And if anyone has any questions on any of the steps, please let me know. I know it's a lot to take in, but just know that in order to get traces, you need to instrument your application. Recommendation is auto instrumentation. You need to have the collector up and running. You need to have an endpoint URL, and then you need to have a config.yaml file that takes that URL. Okay, so now that we have this, all I would need to do is in Sumo Logic, we have a separate way to look at traces. So I'm going to click on the traces and I'm going to check for the last 15 minutes. And you can see that those two services, whatever I set in the environment variables, are coming in. So you can see the trace ID, which is that 16-digit or 16-byte character or string rather of the unique trace ID for every operation. So you can see an HTTP GET, you can see the number of spans, and you can also see the number of errors. And essentially what we're doing is we're collecting there's certain metrics that OpenTelemetry provides us that we're getting. So you can come in here and you can see. So the first troubleshooting step for tracing is you need to figure out if when you come into your environment, do you see traces? If you do, then you've been successful, right? You correctly instrumented it, you correctly have the collector set up. The trouble comes when you don't see traces. Now, remember, there is a little bit of latency. There's like 1 or 2 minute latency for getting traces. So I would give it some time, right? But once that's done, you can see in the traces tab that you have traces. You can expand this to 15 minutes, 60 minutes. Then you can also go into what we have is called a service map. This is, I think, my favorite part because it actually builds out your architecture. And what that means is if you have instrumented your application and if those traces are being sent to Sumo, it will automatically build the map of how the different services are interacting with each other. So I have been doing a lot of testing, so you can kind of see I have a lot of like very interesting servicing names going on here. But as you can see, right, I took the same Flask applications, renamed it multiple times. I kept forgetting what I had named them originally, but you can see, right, that service, that 5081 port calling the 5051 port, you can see that Sumo automatically knows you're doing a REST API call and it builds that map for you. So the reason why I have multiple is I kept changing the names as I was trying it multiple times. So over a 72-hour period, I've tried this multiple times. But essentially what you can also do, and if you wanted to take this one step forward, is actually install SQLite database, which I was trying out the other day. And it'll actually show that, hey, this is a database that you're trying to make a call to. So I was using a service and I was making a call to the database and it built that up. and it'll give you information like latency, requests, error rates, you know, and it even tells me, right, I haven't been running the service for 17 hours. I did it yesterday. So it kind of gives you all of that information. And whenever there's like errors or anomalies, it will highlight that in red. Now, this is like a very simple service. So that's why you don't really see much. But if you were to go into a demo service where we actually have data, right? If I go to a service map, we have something called coffee bar, right? Depending on the application, like they have Python apps, they have Ruby apps. First of all, the diagram changes, right? And it'll also show you how each service interacts with each other, which is the really cool part. You're not only just looking at a log or a metric, you're seeing your overall architecture. So let's see, there's a question in the chat. For grouping, we have microservice A, microservice B, and microservice C. A, B are used with app 1, B, C are used with app 2. What would microservice B export commands look like? Yes, so if I were to go back here, these three commands will be the same, right? It'll be to the collector, to port 4318. And so these two, just remember, these are going to be really dependent on your environment. So there's a doc here that'll talk you through available endpoints, direct connection to the, you know, the endpoint and whatnot. But the main ones that you need to change are the service names. So in your case, probably microservice A, B, and C would have the same application name, but the service itself would be different. So it would be export hotel service name, and then this would be service A, service B, service C, essentially. So in the case of Python, right, I was doing export commands, but if you have a dependency file, you can essentially put all of the, or, you know, wherever you put your environment variables, you can throw all of that in there, and that will help you out. So hopefully that answered your question. Okay, so now we're going to go into the main reason why we're here together. We did a very, you know, very non-real world setup where everything works the first time around. What happens if it doesn't, right? I've given you a few examples of what to look for. But before we go forward, I did want to talk one more point about the config YAML file. There was a lot of stuff in there, and we probably won't be able to get into the full details, but just know that the config.yaml file for the hotel collector has 3 parts. The receiver is how the data is getting into the collector. So we're telling like what data are we collecting. The processors are like, okay, I want to do some processing, and that's more of an advanced topic, but just know you can do things like sampling. Like if you don't want all of your traces, like if your application is super chatty and you want to do sampling, that's when you would run the collector as a gateway mode. And what that will do is it'll allow you to do processing and stuff, right? And we have a really good doc on that. So if you're really interested in doing something like that, this particular doc here, let me pull it up really quick. So we have something called advanced configuration. It'll tell you filtering and shaping of the tracing data, right? It'll say, okay, well, if I don't want to send all my data, you can define, you know, cascading fashion, like how you want to do the probabilistic sampling. So you can see this processors is what's in that config.yaml file that you were using. So I'll put this in the chat. This is more like advanced. I'm not going to be going into this too much, but these are things that you can do, right? Okay, so going back to our slides here. Okay, so we have the receivers, the processors, the exporters. So that's all in that config.yaml file there that we had earlier talked about, where you have the receivers, and we support different things. Like if you're using Jaeger or Zipkin or something like that, we do support it. And then we have the processors, right? And then we have those cascading filters we were talking about. Plus, we do have the exporters, which has the OTLP HTTP. And then, you know, the fact that we're collecting traces, this is the main key portion that kind of combines everything together. All right. So, and I was talking about, okay, now everything works. What if things don't work? What do you do, right? So there's 3 places that tracing can break very commonly. And it's probably self-explanatory at this point, but if you were to look at your architecture, there's 3 places that tracing can break. Either your instrumentation is not done correctly, your collector is not collecting the traces, or the Sumo endpoint is not getting the data. So those are the 3 places where it can break. So we're going to start from step 1, right? You have your application and you want to check whether traces are being generated. That means you have these libraries that you know are supported. You've done your check, right? You've gone to Python, OpenTelemetry, checked if the libraries are supported. That means OpenTelemetry supports them. Even then, you know, you're not getting data. How do you check if instrumentation is working? This is really important. So we already mentioned that, you know, check the traces tab, check the traces index, and check the service map, right? And a couple of the other things like account related. The easiest way to know if your account supports tracing is if you can go into the UI and create an HTTP trace endpoint. And that was what we had done earlier, right? When we had gone into the collection page, we went in here and we created that HTTP traces. If you can do that, that means tracing is enabled for your environment. Most probably a lot of environments are enabled. But if you do see that, I would recommend opening a support ticket if you're not able to do so. Easiest way is also to check if you can just see the traces in your URL or in your UI, sorry. The next couple of things is we do have something called a trace sort of index. So you can essentially open up a log search and it's equal to do underscore traces underscore spans. I believe that's the one. Let me just double check. Yep, underscore traces underscore spans. And when you do a quick search, like I'm going to do 24 hours. Oh, I think it's called something else. Underscore trace underscore spans. So you can see that all of the traces, you can kind of go in here and you can get the parent span ID. So this is like more of a logs view where you can go in and you can take a look at the actual logs. You can see the status codes. So you can do all your like, you know, normal Sumo stuff. So this is like another way to check if you're actually getting tracing data or not. Very basic, simple checks. The next more complicated ones, right? What are the things that generally break? So during my course of testing, the most important thing is if the environment variables are not set up, you're going to get some really interesting errors, right? If you don't have the exporter set up correctly, if you don't have the service name, and you might have noticed like in the UI, when I go to my service map, you might have seen that sometimes there's something called an unknown service. So if you see that, what that basically means is your environment variables just wasn't set up correctly. You might have not set it up, or you might have forgotten about it. So whenever that does happen, you will see like an unknown service and you'll see that in your traces as well. So like if I expand this to 24 hours, I sometimes get unknown services, and that's basically because of that reason. You just haven't set the environment variables correctly, and that could be another reason why things are just not working for you. So it seems like a minor point, very important to check that. So you can do like an echo variable name in the terminal to just see what has been set up. You can do a print environment, etc. Another very, very, very interesting one, and ignore the thing on the left, is if you remember, we had an environment variable called OTel traces exporter, which was sending it to OTLP HTTP. What we're saying is we're sending those traces somewhere else. But what if you want to check on the console to see if the spans for your application, once it's running, are getting generated? So all you would really need to do is you would need to change the environment variable to say export OTel traces exporter console. And you can see, right? I don't want to do it live because it's probably not going to work, as most demos don't on live, but I did take a screenshot to show you. So you can kind of see, right? When I accessed that local host site, because I changed the environment variable in the UI, instead of just showing the fact that the local site was getting access, it actually showed the span ID and the trace ID and the exact trace being generated shown on the UI. So this is like a really great way to see if your instrumentation is done correctly. So it's kind of like a sanity check to see if that works. Another couple of things, some other interesting issues, right, is if your instrumentation is working, maybe, you know, you're not sending it to the collector itself. So this is where the environment variable again comes into play. So the OTLP endpoint, make sure you have the right port. And this is where the documentation is going to guide you, right? So, you know, whether you have the collector host name correctly, like whether it's the right port, all of those things are really important. So, you know, there's documentation that tells you that, hey, these are the different protocols, these are the ports that you have to use. And for ours, it was 4318 for Python, but it could be different depending on, you know, what your setup is. So that is that other portion of where things could be going wrong, right? Where it could be essentially that the instrumentation portion is correct. We've double checked, we've done the sanity check, but now the collector is not collecting the data. So this is like another check you can do in that instance. And I just wanted to share a few interesting things, right? I, at one point, did not set the environment variable correctly. So I was getting a lot of runtime errors saying the OTLP proto is not found. And I realized it was because I didn't have the environment variable. So most often than not, it's usually the environment variables that are going to be causing issues here. Another thing you can do is when you have the site up and running and the collector up and running, there is actually, you can actually go to port 8888 to see the metrics, to see if the spans are being refused by the collector or not. So in this instance, right, hopefully I get this right. So I'm going to just focus on the screenshot here. Give me 1 second. Okay, so I have the collector running, right? I went to this particular one, and I'm going to put this in the chat in case anyone wanted it. But if you go to the local host and go to port 88888 and go to metrics, the OpenTelemetry collector is actually generating metrics that are going to tell you like instance IDs, and the things you need to be looking for are like, you know, has it been successfully sent? It's like, you know, you can see that the OTel collector receiver accepted spans. Hopefully this is not too small. I'll try to increase the size here, but you can see OTel collector receiver accepted spans, and you know, it'll tell you, you know, the number of spans that were refused to be sent over, that were actually accepted, you know, all of the things that can help you determine if it's the collector that's causing the issue. So I'm going to pause really quick there to see if anyone has any questions. I don't see anything, but hopefully this is making sense on, you know, once you get started, where are the different ways that, you know, things can go wrong. A couple of other interesting things I've seen are, you know, if the collector itself, like if you're having a collector running somewhere, if it's not available, you can do a curl command to go to the collector and the port and try to see if the collector is reachable. For localhost, it doesn't really make sense to do that. But if you have like a collector running on a different instance, try to see if, you know, there's any error logs in the OT collector, if you can curl the collector itself. And if it's giving back a status code of without any errors, then you know you're good to go. And the very most common thing, right? Just make sure your Sumo endpoint URL is correct. If you have the collector running and the instrumentation done, if you're not actually able to go in and get the data to the correct URL, it's just not going anywhere at that point. So other interesting errors that I was talking about, right? Service name is unknown service. You know, you just don't have the environment variables. You know, you're having some default applications. That's again, environment variable. So kind of just make sure your environment variables are set up correctly. A common thing that I also see is like dashboards not working. And the most common reason is just that you don't have traces coming in. So when I say dashboards, right? And I'm going to just level set back here really quick. So I'm going to go back to this slide. So we talked about the troubleshooting steps, right? We have the instrumentation, we have the collector, we have the Sumo endpoint, the 3 different ways you can double check where things are breaking. But apart from that, if I were to go back here, if everything works and you're successfully able to see traces and service map, the next portion is to take a look at the dashboard. So there's a lot of out-of-box dashboards that you can use. And this is where we go in, right? So you have the traces tab, you have the service map tab, right? Once you go in here, you can go into the Explorer view and you can take a look and you can see that we have something called the application service view and the service application. So what happens is there are aggregated metrics that you can get from the OpenTelemetry collector data that's being sent over, which we essentially display in the form of dashboards. So you can see here, we can go into the service application view, all of the services that I had created. You can get metrics on the latency. You can see the errors percentages. You can see the traces. You can see that service map view. You can go down and you can see the application for that service, or similarly, you can go to an application. And I think, Matt, your question of like, if you have multiple services, services in an application, this would be a really great view for you, right? You have an application, you can see all the associated services for that application. This is why the naming is very important, right? So you can take advantage of these dashboards. So you can go in here, you can see the operations that are being done within your application. You can go in here and you can kind of look at the metrics behind. So you can see, right, this is metrics that are being generated from the traces, and you can get the application name and the service name and all of those things. So a couple of things you can also do with dashboards. I would highly recommend first taking a look at the out-of-box content. A lot of work was created in making these very easily, consumable for the user. So, common things that you would want to check, right? Errors per second, latency per second, requests per second, service dependencies. What are the traces? What is the duration of the trace, right? So you can go into the trace view. You can actually go in and say, okay, I want to look at all of my applications. I'm going to call Illuminate app, and you can see this root span or any span, and then you can do searches. And once you get here, you can see the trace ID, what is the root service, when it started, what was the duration, what were the number of errors, like what is going on. And you can then go into the actual breakdown of the spans, right? You can go in and see that. This is not a really good example just because, this is test data, but if I were to go into my demo environment and go to traces, right? I can go and look for, number of errors that are greater than like 10. And you can take a look for the last 15 minutes and you can see like which services. You can go in there and you can see, oh, okay, so like this is the entire transaction, and you can see all the different calls, right? You can see that it's going to this, it's doing an HTTP post, then it's going to the coffee bar, it's doing some remote to some other service. And then you can also, look at the error spans only and kind of filter on that, and it'll give you only the error spans. And another thing that I didn't mention, right, as part of advanced configuration, you can actually correlate logs. So if you're collecting application logs, you can inject the trace ID and span ID into the logs. And what that means is if you're collecting those logs into Sumo, you can actually then go in and say, okay, well, I want to see the logs associated to this particular trace. And if you have done that, you can actually go take a look at all the logs with that trace ID and span ID, keeping in mind that you do need to be collecting logs from that application. And that's essentially what this particular document walks you through. So like, for example, for .NET Core, in the application code, you can do things like, oh, I want to inject the trace ID and span ID into my application logs, and then that will actually be generated. And if you have the logs coming to Sumo, you can now correlate traces to logs and have that full observability view. So we have around 4 more minutes, and I just wanted to kind of, if nobody had any questions, just go over where you can get help, right? So we have, of course, our Sumo documentation. So this is really great. And the way I would consume this is, first take a look at the different collection methodologies, get started with transaction tracing, right? How to set up the collection on AWS environments, Kubernetes environments. The one that I was following today was set up traces collection for other environments, meaning that I didn't want to deal with the containerization of anything. And then, of course, the instrumentation of your application with open telemetry. And then there's also another thing on how to work with the tracing data, like once it's coming to Sumo, how do you write the data? How do you view those? And how do you do search query language support for traces? So we do have a question in the chat. So yes, you can put these traces in the dashboard as a panel. That's a really great question. So let's say I create a new dashboard, right? So you can see here, we have a trace list and a service map. So you can go in here and you can basically say, okay, well, I want the coffee bar app and I want any service called calculator SVC to show the dependencies. And you can add this to the dashboard. And this will allow you to put different things like the logs and the metrics. And you can essentially go ahead and have this in a single panel. You can similarly have traces as well, right? You can go in here and you can have those like application is equal to, the coffee bar app, and then just say for any span. And then when you add to dashboard, you can put that on a dashboard. And for monitoring alerting, what you can do is you can use the metrics, right, that are being generated. So if I go to application service view, so there's certain metrics, right? Like if you're tracking errors per second, you can go ahead, open this in metrics. You can essentially go in here and then you can essentially say, let me create a monitor on this, right? So you can say add monitor, And then you can use that query to create monitors and track it. And this is where you can use, again, the application and the service tags that you had input to create that type of alerting and monitoring. So very similar to, again, your just general Sumo Logic alerting and monitoring. You can use those service errors and that content type. So where to get help, apart from, this, I would also recommend checking out, our any of the the support channels, right? We have a lot of places where you can go get help. Opening a support ticket. We have also our community channels like slack.sumologic.com, where there's a tracing channel available as well. So if you're not part of slack.sumologic.com, I'd highly recommend joining here for any questions. There's really great community online that you can ask questions, etc. Definitely. Thank you for joining, Fernando. Appreciate it. And appreciate the questions, everybody. Hopefully this session has been really, really helpful and at least gives you an idea of how to get started. We didn't go into too much details, but just wanted to keep this on the top of your radar. All right. Thank you, everyone, for joining. Really appreciate it. Have a good rest of your day. And if you have any questions, I'm putting my email in the chat. So if you wanted to reach out, feel free to go ahead and shoot me a quick email. I'm happy to answer any questions offline or anything else in the meantime. I'm going to hang out for another 2 more minutes. If you have questions, feel free to hang around. I'm not going to end the session immediately. But thank you for joining. Have a good rest of your day. There's other sessions at Illuminate, so please do join and, enjoy the conferences and all of the on-demand content. Thanks, everyone. Bye. And if you have any questions, feel free to unmute yourself. If not, I will be ending the session in about a minute or so, but thank you for joining. All right, thanks for everyone. I will be closing out the session. Have a good day.